Good afternoon, students. Today, we'll continue our lecture series on fundamentals of organic chemistry. And in this class, we'll study about the next electron displacement effect that is observed in organic compounds, known as electromeric effect.
So electromeric effect is a temporary electron displacement effect that operates in unsaturated organic compounds. Now what do we mean by unsaturated organic compounds? These are the compounds which may be alkenes or alkynes or aromatic hydrocarbons like benzenes and benzenoid compounds or carbonyl compounds like aldehydes and ketones. So what is the common feature of all these compounds? Why are they known as unsaturated compounds? Because you see they have either carbon-carbon double bond, or they have carbon-carbon triple bond, or they have carbon-oxygen double bond. So in all these compounds you will see the presence of pi electrons. This is exactly what happens during an electromeric effect. It involves complete shifting of a shared pair of pi electrons of a multiple bond towards the more electronegative atom. But the main condition is that all these shifting will take place only in the presence of an attacking reagent. So, for electromeric effect to take place, as it is a temporary effect, an attacking reagent is must. As long as the attacking reagent is there, the electromeric will be visible, electromeric effect will be visible, and when you remove the reagent, the effect will disappear and the compound will regain or restore its original condition. So electromeric effect is a temporary effect. It is an electron displacement effect which involves complete shifting of pi electrons from the less electronegative atom to the more electronegative atom. But this will happen only in the presence of an attacking reagent. We will study about an attacking reagent in details in our coming classes, but as of now I'll just give you a brief introduction of what a reagent is. Reagent is a species which may be either electron deficient or it may be electron rich. If it is electron deficient, we call it electrophile. If they are electron rich species, we call them nucleophiles. So reagents may be, attacking reagents may be either an electrophile or a nucleophile. So whatever is the case, when you bring these attacking reagents close to a species, close to a compound which is an unsaturated compound, in such a case electromeric effect will be observed, and it will be observed temporarily as long as these reagents are lying close to the organic compound or lying in presence of the organic compound. As soon as they are removed, the electromeric effect disappears. So now let us see how this happens. Say for example, here in front of you on screen is a carbonyl compound, C double bond O. When you bring the reagent, when you add the reagent for the reaction to take place, there is shifting of this pi electron. One of these electron is a sigma electron, another is a pi electron. There will be no effect on the sigma electron because electromeric effect deals only with the shifting of pi electron. So the pi electron will undergo transfer towards the more electronegative oxygen atom. This happens only when you bring the reagent in close proximity to this organic compound. So as soon as it shifts, the oxygen atom will acquire a negative charge while the carbon atom will acquire a positive charge. This effect is what is known as electromeric effect. Now this reaction is reversible depending upon if you remove the reagent, then this original condition will be restored. So this is what electromeric effect is all about. You bring the reagent, there will be shifting of pi electrons towards the more electronegative oxygen atom here in this case, and you remove the reagent, the original conditions are restored. Coming to the types of electromeric effect, there are two types of electromeric effect. Now in short, electromeric effect is also known as E effect. The two types are plus E effect and minus E effect. So when do these effects are observed? When are these effects observed? Coming to the positive electromeric effect, whenever the transfer of pi electrons take place towards the attacking reagent. In this case, the attacking reagent must be an electrophile. Then only the pi electrons will be shifting towards the electrophile, because electrophiles are electron deficient species. They are in need of electrons. So if the transfer of pi electrons are taking place towards the attacking reagent, then such an electromeric effect will be called as plus E effect. Such things, let us take one example to explain how plus E effect is observed. Say, for example, in electrophilic addition reactions of alkenes, such reactions in which electrophiles are added to the carbon-carbon double bond of alkenes. In such a reaction, you see, H plus can be regarded as an electrophile because it is an electron deficient species carrying a positive charge on it. So, H plus is an electrophile. So, now when this H plus is allowed to react with the alkene, what happens? Shifting of pi electron will take place towards the electrophile, you see. So, the pi electrons are shifting towards the electrophile. Hence, this type of electromeric effect will be called as plus E effect, because the shifting, you see, is taking place towards the attacking reagent, and then when the shifting takes place, the bond will be formed between carbon and hydrogen here in this case, and the other carbon will bear a positive charge. So, this type of effect is called as a plus E effect, positive electromeric effect. Coming to the next type, that is minus E effect, that is negative electromeric effect. In this case, this is just the opposite of plus E effect, so it will be easy to decode. That is when the transfer of pi electrons will be taking place away from the attacking reagent. So, if the transfer of pi electrons are taking away from the attacking reagent must be a nucleophile. That means it must be electron rich, and that is why it is donating the electrons. The electrons are shifting, it is causing the shifting of pi electrons away from it because it's already electron rich, so it doesn't need the electron. Instead of that, it will be donating the electron. Hence, pi electrons will be shifting away from it. So, let us see an example. In case of carbonyl compounds, we know that carbonyl compounds may be either aldehydes or ketones, and they are represented by this general formula. So, in case of carbonyl compounds, let us see the reactions which are called as nucleophilic addition reactions. In such reactions, nucleophiles, that means the species which are electron rich, carries a pair of electron or are negatively charged, they add up to the carbonyl compound molecule. In such a case, what happens? Say, here we have taken one example of carbonyl compound reacting with a cyanide ion. Cyanide ion has a negative charge on it. That means it is a nucleophile. So, when you bring a cyanide ion towards a carbonyl compound, which may be an aldehyde or a ketone, then it will give away its electron towards the carbon atom. Why carbon atom? Because it is less electronegative, as the oxygen atom will pull the pi electron towards itself, like this. So, as soon as you bring, what are the sequence of the steps? First of all, you bring the cyanide ion near the carbonyl compound, and immediately the pi electron will start shifting towards the oxygen atom, and this makes room for the donation of the cyanide ion negative charge, that electron, towards the carbon atom, which is electron deficient, and that leads to the bonding between carbon and cyanide, while the oxygen atom, which has already taken up this pi electron, will have the negative charge. So, this type of effect will be called as a minus E effect. Why minus E effect? Because in this case, the pi electrons are shifting away from the attacking reagent. In plus E effect, the shifting was in this direction. In minus E effect, the shifting is in opposite direction, that is away from the attacking reagents. So, this is all about the two types of electromeric effect, that is plus E effect and minus E effect. So, we have to note one thing here, that in some of the organic compounds, the inductive effect and the electromeric effect, they may occur together, and when they occur together, they may either support each other or they may oppose each other. If in case they are opposing each other, then you have to remember that the electromeric effect will always predominate, and that will guide the chemical characteristics or chemical reaction or chemical properties of that particular compound. So this has to be kept in mind while studying the chemical reactions of compounds, that electromeric effect always predominates the inductive effect whenever they are occurring together in a molecule, whether they are supporting or opposing. In case they are opposing, the electromeric effect will always predominate. Now let us understand this electromeric effect with the help of an easy example. Benzene undergoes many electrophilic substitution reactions. Say for example, when you treat benzene with chlorine gas in the presence of a Lewis acid, say anhydrous AlCl3, anhydrous aluminium chloride, which acts as a Lewis acid catalyst here. In such a case, benzene will react with chlorine and it give us chlorobenzene. Now during this reaction, what happens is, first of all, chlorine Cl2 will break down to give us a Cl plus ion, and because it is happening in the presence of anhydrous AlCl3, so the other thing that we get is AlCl4 minus. Now the Cl plus acts as the electrophile. So what it does here, it reacts with the benzene, and you see how the electromeric effect will take place. Plus Cl plus, Cl plus. So when this happens, the pi electron will be shifting towards the Cl plus ion because the Cl plus is in need of an electron. So the pi electron will shift towards the Cl plus ion. So this is a type of plus E effect, positive electromeric effect, and this will give rise to an intermediate like this. Yeah, here a hydrogen atom in the benzene ring is already present like this, and because the pi electron was shifting from this carbon, so this carbon will now bear a positive charge. And in the next step, now this is an intermediate, this is unreactive, this is unstable, and so this will break down and this hydrogen will be eliminated. So what you get here is this. So pi bonds come back and Cl. So H plus ion is eliminated, and in place of that a Cl plus ion is attached to the benzene ring. This is called chlorination of benzene in the presence of anhydrous AlCl3, and this starts with electromeric effect. If you can see, this is the plus E effect taking place in the very first step of this reaction. So this is how electromeric effects are observed in many organic chemistry reactions. In our next class, we will study about the third electron displacement effect, that is resonance effect. Thank you.